Welcome to the Deep Dive, your shortcut to being well-informed, fast. Today, we're diving headfirst into one of the tech world's most enduring debates, PostgreSQL versus MySQL.
Yes, the classic showdown.
For anyone building or maintaining software, this question inevitably pops up. Which one is right for your project?
It's a question that echoes through development teams globally, isn't it? Our mission today is to kind of cut through the noise, demystify their core strengths, weaknesses, and ideal use cases.
Right.
We'll give you those essential nuggets of knowledge so you can confidently understand which database is best suited for various scenarios, and maybe most importantly, why.
And here's where it gets really interesting, because beyond simply picking the right database for a specific task,
Yeah.
maybe PostgreSQL for your financial analytics and MySQL for your high-traffic e-commerce site, there's an even bigger challenge.
Okay, what's that?
Especially as your tech stack expands, how do you manage secure, consistent, and auditable access across both of them, without creating a security nightmare or slowing your team down?
The access problem. Yeah. That's the real conundrum we'll unpack by the end of this deep dive.
Exactly.
Absolutely. So let's begin at the beginning. What is a database management system, or DBMS?
Good starting point.
Think of it as the brain for your data, the software that lets you define, organize, store, and retrieve information. While both PostgreSQL and MySQL fill this role, their underlying philosophies diverge quite significantly.
That's right. MySQL, for instance, traditionally leans into being a purely relational database. Its core design prioritizes simplicity and sheer speed.
Get in, get out fast.
Exactly. It's built to get data in and out quickly, perfect for straightforward transactions. Now, it has evolved with recent JSON support adding some semi-structured capabilities, but at its heart, it's a speed demon. PostgreSQL, on the other hand, is considered an object relational database.
A bit different.
It's known for its rich feature set, incredible extensibility, and often a greater degree of complexity.
Which makes it a go-to for really intricate queries and demanding write-intensive workloads. That foundational difference in philosophy influences everything else. Take standards and compliance, for example. PostgreSQL is arguably the most SQL-compliant among open-source relational database management systems.
Really sticking to the rules.
Yeah, it rigorously adheres to ANSI SQL standards and offers native support for advanced SQL features. We're talking about things like window functions, powerful operations that perform calculations across rows.
Super useful for analytics.
Totally. Allows for very sophisticated analytics directly in your database. Or recursive queries, which let you navigate hierarchical data, say an organizational chart.
So PostgreSQL is like the strict rule follower. And MySQL, while hugely popular, has historically been a bit more flexible, or shall we say pragmatic.
Exactly. MySQL has historically traded off some SQL compliance for performance and ease of use. While recent versions have made strides, it still lacks support for certain advanced SQL constructs.
Especially with some engines, right?
Particularly when you're not using the NODB engine, which is their more modern and robust option. It's a trade-off for simplicity and speed in many common scenarios.
And when it comes to extensibility, PostgreSQL truly stands out. It's often referred to as its beating heart.
That's a good way to put it.
You can actually define custom data types, operators, indexing methods, and even load powerful extensions like PostGIS for spatial data.
Turning it into a GIS database, basically.
Yeah. MySQL is less extensible by comparison. While plugins exist, getting them to work often requires deeper internal knowledge, and you might find yourself limited to built-in syntax and storage engines.
That difference also impacts how they handle views. PostgreSQL supports both regular and materialized views.
Materialized views, those are the pre-computed ones.
Exactly. Pre-computed results of expensive queries stored for swift read access. Think of it as a cache report you can refresh on demand, ideal for complex joins or aggregations.
Makes sense. And MySQL.
MySQL, however, only supports non-materialized views, meaning the query runs every single time you access the view. No pre-computation there.
Okay, diving into ACID compliance and architecture. PostgreSQL takes a very stringent approach.
Super important topic.
It adheres rigorously to the ACID principles: atomicity, consistency, isolation, and durability. This means it facilitates full transaction isolation, even serializable isolation.
Which is the highest level.
Right, where transactions behave as if they run one after another, absolutely crucial for demanding use cases like financial systems or anything needing ironclad data integrity.
And this is a critical differentiator. MySQL does support ACID transactions, but primarily via its NODB storage engine.
Ah, the engine dependency again?
Yep. If you're using their older MyISAM engine, for instance, it is not ACD compliant. This can be a source of confusion and potential data integrity issues if you're not careful.
Good to know.
Plus, MySQL's default configurations often lean toward speed over the strictest isolation, which can be fine for many web applications, but is a consideration for others.
And architecture-wise, they're different there too.
Very different. Architecturally, PostgreSQL uses a process-based design. Each connection spins up a new OS process.
Okay. Benefits, drawbacks.
High stability, for one. A faulty connection can't crash the entire server, but it can be a bit more memory-intensive per connection.
Gotcha. And MySQL.
MySQL, on the other hand, uses a thread-based architecture. This scales really well for thousands of lightweight connections, consuming less memory per connection.
Making it great for web apps with lots of users?
Exactly. An excellent fit for web applications with many concurrent users.
So if PostgreSQL is like having a dedicated concierge for every database connection,
I like that.
MySQL is more like an efficient, high-volume queue.
That works.
Let's shift gears and look under the hood at their performance and modern capabilities, starting with data types and query optimization.
Sure. PostgreSQL definitely has a richer palette of native and custom data types. We're talking about native JSON and JSONB.
JSONB is the binary one, right? Allows indexing.
That's the one. Binary JSON that supports indexing deeply nested keys. Huge deal. Also arrays, HS-store for key value pairs, UUIDs, XML, IP address types.
And you can even make your own.
Yep. You can even define your own custom types for domains. Really flexible.
Wow. How does MySQL compare there?
Well, MySQL supports the common types, INT, varchar, date, and it added JSON support back in version 5.7. But it still has shortcomings in native JSON indexing and lacks native array data types.
So that richness in PostgreSQL impacts queries too.
Absolutely. That richness directly impacts query optimization. PostgreSQL boasts a sophisticated query planner and optimizer. It supports advanced features like common table expressions or CTEs.
CTEs, great for readability.
Exactly. Name temporary result sets you can reference within a single SQL statement, making complex queries more readable and efficient. This makes it incredibly powerful for analytical workloads and handling complex joins.
And MySQL's optimizer.
MySQL's Query Optimizer works quite well for simpler queries. But as your tables grow and queries become more complex, especially with multi-level joins, it can struggle.
Meaning you might need workarounds.
Sometimes, yeah. You might need to denormalize your data or build workarounds at the application level.
It sounds like PostgreSQL is built for the database heavy lifting and MySQL for more straightforward, maybe read-heavy transactions.
That's a fair generalization, yeah.
Both databases use multi-version concurrency control, or MVCC, right, to handle concurrent transactions.
They do. MVCC ensures readers don't block writers and vice versa, but their implementations differ.
How so?
PostgreSQL's MVCC is renowned for its robustness. It offers fine-grained row-level locks, snapshot isolation, and advanced control over deadlocks and transaction consistency. Very solid.
And MySQL.
MySQL's MVCC, primarily through NADB, relies on undo logs to manage different versions of rows. It works well, but it tends to have more limited isolation levels compared to PostgreSQL's full spectrum.
Okay, let's talk performance scenarios. It's not always clear-cut, is it?
Definitely not a one-size-fits-all answer. For read-heavy applications like content management systems, forums, or dashboards where you have tons of users reading data, but maybe not a lot of complex writes, MySQL is often incredibly fast, blazingly fast sometimes.
But if the workload shifts?
Right. If you have workloads that are write-heavy, constantly dealing with complex transactions, intricate indexing, and triggers, PostgreSQL really shines. It handles those sophisticated operations with greater efficiency.
And for really complex queries, like analytics?
Precisely. For truly complex query handling, things like recursive queries, multi-level joins, subqueries, or nested selects, PostgreSQL's execution engine and optimizer are simply more advanced, miles ahead sometimes.
So with MySQL, you might end up doing more work in the app.
Often, yes. MySQL often requires you to do a lot of the heavy lifting in your application code or resort to denormalizing your data to achieve similar performance for those complex cases.
And this ties back to resource use, too.
It does. This also leads to differences in resource utilization. PostgreSQL, due to its process-based architecture, might consume more memory per process, which contributes to its stability, but MySQL generally has a smaller memory footprint.
Better for shared hosting or containers, maybe.
Exactly. A good fit for shared hosting environments or containers where resources are tighter.
Let's do a deeper dive into how they handle JSON and stored procedures, because this is where a lot of modern applications live.
Good idea. This is a big differentiator.
PostgreSQL's JSON-B capabilities sound incredibly versatile, like almost a document store.
It practically doubles as one. You can index deeply nested keys, run JSON path queries, which are essentially powerful ways to navigate and extract data from within your JSON documents.
So you can query inside the JSON effectively.
Exactly. And store logs, telemetry, or user settings without needing to change your database schema constantly. It really helps bridge the gap between traditional, relational, and NoSQL databases.
Offering a kind of hybrid approach.
You got it. MySQL's JSON support is improving, and it's certainly useful for basic JSON storage, but it still lacks that native indexing and those advanced query capabilities for complex JSON structures that PostgreSQL offers.
And stored procedures. Big difference there, too.
Quite a bit. As for stored procedures, PostgreSQL supports them in a variety of languages beyond just SQL. Think PL/PG/SQL, Python, JavaScript, even C.
Wow, multiple languages.
Yeah, this gives you a significant edge in encapsulating advanced complex logic directly within the database layer, which can be very powerful.
And MySQL, more limited.
MySQL's stored procedure functionality is more limited, primarily restricted to SQL. Still useful, but not as flexible.
Okay, what about keeping the lights on? Replication and high availability.
Both are strong here, but with different flavors. PostgreSQL provides comprehensive choices: streaming replication, logical replication, hot standby.
Logical replication is interesting. Replicating changes based on data, not just physical blocks. Exactly, more flexible. And it supports multi-master setups, often with third-party tooling like BDR or Citus. Plus, it can often handle zero-downtime schema changes, which is huge.
And MySQL's options.
MySQL also offers strong options like group replication, multi-source replication, and read replicas. Very capable.
So both get you high availability.
Oh yeah, both can achieve high levels of availability, but PostgreSQL generally allows for more granular control over your replication setup, which can be crucial for very specific recovery point objectives, RPOs, and recovery time objectives, RTOs.
All right, let's talk strategic considerations. How do these two databases stack up when you're thinking about scalability and integrating with cloud platforms?
Good question. For scaling, PostgreSQL supports table partitioning natively, sharding, often via extensions like Citus or increasingly native features, and parallel queries to handle growing data volumes.
So it scales vertically and horizontally. Increasingly well, yes. MySQL, with its thread-based architecture, is often chosen for horizontal scaling with read replicas and clustering via MySQL cluster, though multi-writer setups can get quite complex.
And cloud support. Everyone's in the cloud now.
Good news is, both enjoy full support from major cloud providers like AWS, Azure, and GCP through managed services like RDS, Cloud SQL, and Aurora. No worries there.
Any edge for one over the other in the cloud-native world?
Well, PostgreSQL often has a slight edge in its cloud-native integration. It benefits from its stronger standards compliance and seems to integrate really seamlessly with infrastructure as code tooling like Kubernetes and Terraform.
Okay. And MySQL?
MySQL, on the other hand, provides strong support for traditional LMP stacks and lightweight cloud deployments, making it a quick go-to for many web apps.
And AWS Aurora, they have versions for both, right?
They do, and they're a bit different. Aurora PostgreSQL aims to provide superior performance while staying quite close to vanilla PostgreSQL. Aurora MySQL, while offering enhanced replication and quicker failovers, actually diverges more significantly from stock MySQL in its implementation. Both offer great high availability, though.
Interesting distinction. Okay, developer experience. That's crucial. How do they play with popular frameworks like Django?
Django. PostgreSQL is actually the default and often recommended backend for Django.
Why's that?
Precisely because of its feature-rich SQL dialect. While Django does support MySQL, some advanced ORM features within Django specifically leverage PostgreSQL's capabilities to function fully. You get more out of Django with Postgres.
What about Laravel, another popular PHP framework?
Similar story, really. When it comes to Laravel development, PostgreSQL slightly edges out MySQL. It enables more eloquent ORM capabilities, ORMs being object relational mappers, letting you work with objects instead of raw SQL.
Makes development easier.
Definitely. And PostgreSQL offers better handling of JSON and constraints within Laravel. But the great news is, both databases enjoy extensive support across popular ORMs like Squalchemy, Hibernate, Doctrine, and Prisma.
So you can use either with most tools?
Absolutely. Ample unrelenting support. However, PostgreSQL consistently unlocks more advanced ORM features simply because of its broader SQL compliance.
Right. That SQL compliance keeps coming up.
It's a recurring theme.
And of course, security. Paramount for any data infrastructure. How do they compare on built-in security features? Authentication, maybe?
Good point. PostgreSQL offers a wider range of authentication methods out of the box. Password, LDAP, Kerberos, SSL certificates gives you more flexibility.
And
MySQL primarily relies on password authentication. LDAP and PAM are available, but typically in its enterprise edition, so it's a bit more constrained there in the open source version.
What about controlling who can access what data? Access control.
Another area where PostgreSQL shines with granularity. It provides very granular roles, row-level security, meaning you can literally control access to specific rows of data based on policies.
Wow, down to the row level.
Yeah. And robust policy enforcement. MySQL offers user privileges at the schema and table level, which is effective, but just not as fine-grained.
Okay. And encryption, data in transit, data at rest.
Both handle encryption in transit via SSL TLS. That's standard. For encryption at rest, PostgreSQL often relies on file system encryption or extensions like PG Crypto. MySQL also supports SSL in transit, but its built-in transparent data encryption, TDE, for data at rest is only available in its enterprise edition.
Ah, another enterprise feature for MySQL. That's a key consideration for compliance, isn't it?
Absolutely, especially for things like PCI DSS or APA.
So what if you're already on MySQL but are contemplating a leap to PostgreSQL? We hear about this sometimes.
It's a common consideration, yeah. Often driven by the desire for PostgreSQL's superior data integrity, that greater extensibility we talked about, and the advanced SQL support.
But migrations are never trivial.
Right. No. You will inevitably face migration challenges. These include differences in data types, variations in indexing behavior, and particularly divergent SQL dialects that affect stored procedures and triggers.
So not just a simple data dump and load.
Rarely. While tools like pgloater, AWS Database Migration Service, DMS, and ORDBMS can help automate parts of the process, you should definitely be prepared for some manual effort. Converting stored procedures, triggers, adjusting application logic, it takes work.
And that strict type system in PostgreSQL might catch things.
For sure. PostgreSQL's strict type system calls for careful validation during migration to avoid unexpected data errors or silent failures.
Okay. What about integrating with other databases? Does one have an edge there?
PostgreSQL has a really powerful feature called foreign data wrappers, or FDWs.
Foreign data wrappers. What exactly are those and what's the big deal?
FDWs are a unique set of libraries that allow PostgreSQL to connect not just to other PostgreSQL instances, but even to non-relational databases like MongoDB or Redis.
Seriously, connect to NoSQL databases.
Yeah, and treat that external data as if it were a local table within PostgreSQL. This enables advanced query pushdown, meaning PostgreSQL can offload parts of a query to the remote system, which is incredibly efficient.
Wow, that sounds powerful. How does MySQL compare?
MySQL, by contrast, includes federated tables. It's a more localized feature primarily for referencing tables in remote MySQL instances. It's effective for that specific use case, but it's not quite as robust or as actively developed as PostgreSQL's FDW ecosystem.
So after all this, hours could be spent debating. When do you choose which?
Yeah, the million-dollar question. There's clearly no single best database. It truly boils down to your specific workload, your data complexity, and your compliance needs.
Okay, let's break down. When is PostgreSQL the likely winner?
Precisely. You typically choose PostgreSQL for applications demanding stringent ACID compliance and strong data consistency. Think fintech, insurance, anywhere data accuracy is absolutely non-negotiable. It's also ideal if you need sophisticated queries, require robust JSON or NoSQL data handling, geospatial analytics, or if your tech stack includes frameworks like Django or Rails, or advanced analytics tools often seen in healthcare, government, or the public sector.
So complexity, compliance, advanced features point to Postgres.
Generally, yes.
On the flip side, when is MySQL often the go-to?
MySQL shines when you're prioritizing performance for read-heavy workloads. Think content management platforms, blogs, e-commerce sites where lots of people are browsing, or applications in media and retail.
High-volume reads.
Exactly. It's also fantastic for situations requiring simplicity and quick setup, making it perfect for MVPs or startups trying to get off the ground fast.
And the LMP stack connection.
And of course, it's the standard for applications heavily dependent on the LMP stack, or widely used tools like WordPress. That's why it's so popular in marketing and ad tech teams for high-traffic dashboards and real-time reporting systems. Simple, fast, gets the job done for many web use cases.
Okay, that brings us back to that real-world challenge we mentioned at the start.
Right, the access management piece.
Because while both PostgreSQL and MySQL offer distinct advantages, PostgreSQL for complex, write-heavy stuff, MySQL for fast reads teams often end up using both, right?
Very common scenario, yes. You pick the best tool for the job, and often that means using multiple tools.
So the core problem isn't just making the initial choice, it's managing secure, consistent, and auditable access across these disparate environments, especially as your team and data grow.
And that's where things can get messy. Managing credentials, network access, audit logs across different database types, it becomes a huge headache and a security risk.
Exactly. And this is where a unified access management layer becomes absolutely critical. Think of it as a single control plane for all your database access.
A necessary abstraction layer, really.
Mm.
So what kind of capabilities should you look for in a solution like this?
Well, first, centralized access controls. This means managing permissions for both your PostgreSQL and MySQL databases from one place. You enable role-based access, right?
Right, map roles to database permissions.
And it eliminates the need for sharing database credentials or managing complicated SSH tunnels. Plus, it makes onboarding and offboarding team members seamless with automatic permission updates. Huge time saver, huge security win.
Okay, centralized control. What else?
Second, it needs to enforce a zero-trust access architecture.
Zero trust. Buzzword, but important. What does it mean here?
It's a fundamental security principle where every single request to a database is authenticated and authorized in real time. No implicit trust. This seriously reduces your overall risk.
So continuous verification.
Exactly. A good solution supports modern security features like single sign-on, multi-factor authentication, and device trust. And critically, it removes the need for VPNs or static credentials for database access.
Okay, makes sense. Control, zero trust. What's third?
Third, it provides full visibility into activity. This is huge for security and compliance.
Knowing who did what, when.
Precisely. You gain complete insight into who accessed what, when, and why across both your MySQL and PostgreSQL environments. This includes real-time session logs and even query-level visibility.
Down to the specific query they ran.
Yep. You can even replay sessions to support forensic investigations or audits. Invaluable for meeting compliance requirements like IPA, SOC2, and PCI DSS.
That level of auditing is critical. Okay, one more.
And finally, such a solution needs to be secure and scalable. It should be built to handle access at enterprise scale, working seamlessly across cloud, on-prem, hybrid, and multi-database environments.
Needs to grow with you.
Right. It should support dynamic access grants with just-in-time provisioning, granting access only when it's needed and for a limited time.
Least privilege just in time. Good principles.
And provides robust protection against common threats like misconfigurations, insider threats, and maybe most commonly, over-provisioning of permissions.
Yeah, giving people access they don't really need anymore.
Yeah.
Classic problem.
The outcome here is clear. Whether you're scaling a startup, running complex enterprise analytics, or building high-traffic applications, unifying your database access ensures your PostgreSQL and MySQL environments remain secure and compliant.
Without slowing your teams down. That's the key, isn't it? Security that enables, not hinders.
Exactly. It has to work for the people using it.
So to bring it all together, there's truly no single best database. The choice between PostgreSQL and MySQL ultimately boils down to your specific workload, your data complexity, and your compliance needs.
You really have to analyze your specific situation.
No silver bullet.
And no matter which path you take, or if you find yourself, like many teams, using both.
Which is increasingly common.
The critical takeaway from this deep dive is the paramount importance of unifying and securing access across your entire data infrastructure.
Right.
That challenge only gets bigger over time.
It really does. The database choice is step one. Managing access consistently and securely is the long game.
So here's a final thought to leave you with.
Okay.
In a world where data types and workloads are constantly evolving, where we see this blend of relational, NoSQL, JSON, what does this ongoing database evolution mean for how you approach your data infrastructure and its security, especially when you're blending different technologies like PostgreSQL and MySQL?
How do you secure a constantly shifting landscape? Something to chew on.